Hello students, welcome to grade 10 mathematics. Today's topic is linear equations in two variables part 1. Linear equations in two variables. General form for a linear equation in two variables is ax plus by plus c is equal to 0, where a, b and c are real numbers. This type of equation is called a linear equation because when we represent it as a graph, we get a straight line. All the points or values of x and y which satisfy this equation are called its solutions. Geometrically, it means that these points lie on the line represented by this equation. Since by definition a line is a collection of infinite number of points, a single equation, that is a linear equation, will have infinite solutions as all the points will be lying on it. Theoretically, if we take two linear equations and solve them, we have three situations, namely a unique solution, no solution, infinitely many solutions. Let's see. Graphically, when we view it, unique solution means two lines will be intersecting at one point. No solution means the two lines will be parallel to each other. And infinitely many solutions means the two lines will be coincident. That means they will be lying one over the other. General form of a set of linear equations. Usually, linear equations in two variables occur in pairs because we have to solve them theoretically and we are able to apply the method easily since there are two variables. So, two equations are required to find a solution. Conditions of consistency. If a1 upon a2 is not equal to b1 upon b2, then we will have a unique solution. That means the lines will be intersecting at one point and that point will be called its solution. If a1 upon a2 is equal to b1 upon b2 is not equal to c1 upon c2, then we have no solution. That is, the lines will not intersect. That is, they will be parallel, or we can also say that they will be inconsistent. And this is their graphical representation. The two lines will be parallel. They will have no point of intersection. Third condition of consistency is a1 upon a2 is equal to b1 upon b2 is equal to c1 upon c2. That is, the ratio of the coefficients of x and y is equal to the ratio of the constants. This implies infinitely many solutions. We can also say the lines will be coincident. They will represent the same graph. That means they will be consistent. The graphical representation is that they will be overlapping each other or they will be coincident. Question number 1. Check whether the given set of equations is consistent or inconsistent. How many solutions will it have? Y minus 4x is equal to 1. 6x minus 5y is equal to 9. First, we write the equations in the standard form. What was the standard form of linear equations in two variables? It was a1x plus b1y plus c1 is equal to 0 and a2x plus b2y plus c2 is equal to 0. Here a1, a2, b1, b2 and c1, c2, they were some real numbers. So this is called the standard form of the linear equation. So we try to convert this in standard form. That means first the term with x will come and then with the y will come. And we try to bring the constant term before the equality sign. That is minus 4x plus y minus 1 is equal to 0. And this is 6x minus 5y minus 9 is equal to 0. Now take out the values of a1, a2, b1, b2 and c1, c2 by comparing it to the standard form. So here a1 upon a2 will be minus 4 upon 6, that is minus 2 upon 3. b1 upon b2 will be 1 upon minus 5 and C1 upon C2 will be equal to minus 1 upon minus 9. Minus and minus sign cancels and I have 1 upon 9. And here we notice that A1 upon A2 is not equal to B1 upon B2. Therefore, this set of equations has unique solution. That means the set of equations is consistent. Let's revise quickly. Conditions of consistency say that if A1 upon A2 is not equal to B1 upon B2, then we have unique solution. If A1 upon A2 is equal to B1 upon B2 but it is not equal to C1 upon C2, then we have no solution. And if A1 upon A2 is equal to B1 upon B2 is equal to C1 upon C2, then we have infinitely many solutions. Next question. Without drawing the graphs, find out whether the lines represented by the following pair of equations intersect at a point, are parallel or coincident. The equations are 18x minus 7y is equal to 24. 9 upon 5x minus 7 upon 10y is equal to 9 upon 10. First of all, we try to write them in the standard form. That is, 18x minus 7y minus 24 is equal to 0. 9 upon 5x minus 7 upon 10y minus 9 upon 10 is equal to 0. Now, I want to get rid of the denominator here. For that, I will multiply this equation by 10. If I multiply it by 10, I will have here 10 into 9 upon 5x minus 10 into 7 upon 10y minus 10 into 9 upon 10 is equal to 9 into 10. Here 5 and 10, this gives me 2. 10 and 10 cancel, 10 and 10 cancel. So I am left here with 18x minus 7y minus 9 is equal to 0. Now let us name this equation as number 4. So we have third and fourth equations now which are in standard form. Now next step is that we find the values of A1, A2, B1, B2, C1, C2. Then find the ratio A1 upon A2. This will be 18 upon 18 equal to 1. B1 upon B2 will be equal to minus 7 upon minus 7 is equal to 1. C1 upon C2 is equal to minus 24 upon minus 9, which gives me 8 upon 3. So I notice that A1 upon A2 is equal to B1 upon B2, but it is not equal to C1 upon C2. Therefore, the given system of equations has no solutions. No solution means the lines will be parallel. Next question. If the system of equations 6x plus 2y is equal to 3 and kx plus y is equal to 2 has a unique solution, then find the value of k. These are applications of conditions of consistency. Here, the equations are 6x plus 2y is equal to 3 and kx plus y is equal to 2. Let us write them in the standard form. 6x plus 2y minus 3 is equal to 0. Kx plus y minus 2 is equal to 0. Next step, we find a1 upon a2, b1 upon b2 and c1 upon c2. a1 upon a2 is 6 upon k, b1 upon b2 is 2 upon 1. And C1 upon C2 is minus 3 upon minus 2, that is 3 upon 2. Now, for unique solution, we have that A1 upon A2 is not equal to B1 upon B2. That means 6 upon K is not equal to 2 upon 1, which gives me, on solving, 6 into 1 is not equal to 2 into K. That is, K is not equal to 3. Hence, k may have any real value except 3 if we want that this system of equation should have unique solution. Question number 4. Determine the value of m and n so that the following pair of linear equations has infinite number of solutions. 2m minus 1 into x plus 3y is equal to 5 and 3x plus n minus 1 into y is equal to 2. Write them systematically. Now, for infinitely many solutions, a1 upon a2 is equal to b1 upon b2 is equal to c1 upon c2. Notice here that I have not shifted c1 and c2 on this side, because when I was dividing, then the signs were getting cancelled and I was getting 3 upon 2. Whether I had taken 3 upon 2 on the 3 and 2 on this side, then also c1 upon c2 would be there. Would be 3 upon 2 when they were here, then also it is 3 upon 2. So here either both the c's should be towards the right side of the equality sign, or both of them should be towards the left hand side. So here I am taking 2m minus 1, that is coefficient of x, upon 3 is equal to 3 upon n minus 1 is equal to 5 upon 2. First 2 can be taken to solve here, and then we can take this one, second and third one. First we are taking first and third, and then second and third. First and third, they give me 2m minus 1 upon 3 is equal to 5 upon 2. This gives 4m minus 2 is equal to 5 into 3, that is 15, which implies m is equal to 17 upon 4. Then 3 upon n minus 1 is equal to 5 upon 2 gives me 6 is equal to 5n minus 5. That means n is equal to 11 upon 5. Question number 5. For what value of k will the pair of equations have no solution? The pair of equations given are 3x plus y is equal to 1 and 2k minus 1 into x plus k minus 1 into y is equal to 2k plus 1. Given equations are 3x plus y is equal to 1, 2k minus 1 into x plus k minus 1 into y is equal to 2k plus 1. For no solution, a1 upon a2 should be equal to b1 upon b2 should not be equal to c1 upon c2. So here we put the values. We get 3 upon 2k minus 1. 3 upon 2k minus 1 is equal to 1 upon k minus 1 is not equal to 1 upon 2k plus 1. We will consider because we have to find the value of k, so we will be considering the first two parts of this. Here I have 3 into k minus 1 is equal to 1 into 2k minus 1. This gives me 3k minus 3 is equal to 2k minus 1, which implies 3k minus 2k is equal to minus 1 plus 3. This implies k is equal to 2. Hence, for k is equal to 2, the system has no solutions. Thank you and happy learning.